In this video, we're going to talk about direct variation. Go ahead and pause the video, copy down your lesson title, standards, and I can statement, and then we'll get started. Okay, so we need to start by defining exactly what constant of variation is, or direct variation. So the first thing I want you to write down is that the slope, which we have been finding in the last couple of sections, the slope and the constant of variation are the exact same thing, okay? So they have very similar equations, and we'll get into that in just a second. But basically, direct variation just means that two values, like an x and a y value on a graph, they change at the same exact rate. So, for instance, if you double x, then y will also double. If you triple x, then y will also triple. So the ratio of the change is always the same, okay? That's all that means. Now, here's a copy of what my notes look like, just to give you an idea of the layout, because there's a lot of things in this video that you're not going to copy down. So here's an example of what my notes look like, and you can always go back and review that. But keep in mind that I don't want you to just sit and write down what I've got and not watch the video, okay? So let's get started. We are going to name the constant of variation for the equation, and then we are going to find the slope of the line. So basically, if you're given a line on a graph like the one at the right, or if you're given 2 points, all you have to do is find the slope, because if you find the slope, then that is also the constant of variation. Okay, so remember from last section you had your slope formula, and I'm going to highly recommend that you memorize this formula because we will use it the rest of the year. So basically, you copy down your points. So you've got 0, 0, and you've got 1, 2. Now remember from last section, you start out by labeling your points, first coordinate and your second coordinate, and then you just plug them into the formula. So you have 2 minus 0 over 1 minus 0, and so you have 2 over 1. So remember, that's the slope, and that is also your constant of variation. And that's it. That's all you have to do. Okay? So let's do another one. Go ahead and pause the video and give this one a try. So remember, you start by copying down your points. So you've got 1, negative 4, and 0, 0. You label each of your points, and then you plug them into the formula. So you have negative 4 minus 0, and you have positive 1 minus 0. So it's negative 4 over 1. So your slope, or your constant variation, is negative 4. Okay, so let's move on to actually using the formula. Now, don't sit here and copy everything down. Basically, you need the highlighted portion. So you have y equals kx, and k cannot equal 0, okay? So you have y equals kx, where k is your constant of variation, that's your slope, and then each and every direct variation graph passes through the origin. So you automatically know one of the points when it comes to that equation. All right, now, don't sit and copy the two graphs down either. You have the Mr. Slope guy from the last section to remind you what a constant, or what a positive and negative slope are. So just keep in mind that if your constant is greater than 0, that's your slope, then your line is going to go uphill, okay? If your constant is negative or less than 0, then that gives you a negative slope, all right? That should kind of be, hopefully, second nature by now. Okay, so let's move into graphing a direct variation equation. Now, if you notice, this equation is in the form y equals kx. So notice that the slope is the negative 3 over 2, okay? So basically, you just put a dot at 0, 0, okay? And then what you're going to do then is move from that point at 0, 0. You're going to go down 3 units and you're going to go right 2 units. Now, I want to point out here that notice that the whole fraction right here is negative. So what you're going to do is you're going to throw that negative up top and then forget about it. So that's why you go down 3 units, is because that 3 is negative, okay? So then from 0, 0, you go down 3 units and right 2 units, and you draw another dot, and then you just draw a point connecting the lines. So your 0, 0 point is right here, and then you're going to go down 1, down 2, down 3, and then you're going to go right 1 and right 2, and then that's how they get the other dot, and then you just connect the points. So that's what they've done here, okay? So notice that you've got your slope is negative, it's less than 1, so you better have a negative or downhill slope, okay? That's all you have to do to graph those. And if instead of the negative 3 over 2, say it was y equals 2x, then you just turn the 2 into a fraction, and then so you would go up 2 and right 1, okay? That's all you have to do there. So let's move into writing direct variation equations when we're given our parameters or limits. So remember, you want to start with your formula always, okay? And then what you're doing is you're just plugging values in. So if y varies directly as x, that's always your clue that it's a direct variation, okay? And they give you y equals 9 when x equals negative 3. So they're giving you 2 values, and you have to find the rate at which those values are changing. So we're going to find k. So all you have to do is plug x and y into the formula, okay? So my y value is 9, and my k is what I need to find, and remember that's multiply when they're side by side, and then my x value is negative 3, okay? And now you're just going to solve that for k. So remember that if we are multiplying to get rid of the negative 3, we're going to divide on both sides. And so what that does is leave you with a negative 3 equals k. So your constant change, or your slope, is negative 3. Okay? So now we're going to take that answer and move into the next example. So remember, we had negative 3 as our constant, right there. So then now we're going to find the value of x if y is 15. So again, you start with this equation that you've got, and you plug 15 in for y, negative 3x, and then of course in order to solve that, you're going to divide by negative 3 on both sides. And so when the y value is negative 15, your x value is going to be negative 5. And that's it. That's all you have to do. Okay, so I have one more example, one more set of examples. So go ahead and pause and give these a try. Okay, so remember that you want to start with your direct variation formula. And then so you plug 15 in for y and 5 in for x. So you've got 15 equals k times 5, and then on both sides you are going to divide by 5, and so your k value is 3. Okay, and then we're going to use this value, okay, because this turns into the formula y equals 3x, okay? So we're going to use that in the next one, all right? So suppose that y varies directly as x and y equals 15 when x equals 5. So use the direct variation equation to find x when y is 45. So use your y equals 3x from the other one and give this one a shot. So when you plug negative 45 in for y, okay, you're going to divide by 3 on both sides, and so your x value is negative 15. Okay, and if you notice that, if you look at your x values and your y values that you were given, their difference or their change is by 3. Okay, so that's basically it for direct variation. Bring your questions to class and we will work on the assignment tomorrow.